everyone. Our topic for today is about integration by trigonometric substitution. So at the end of this lesson, you should be able to evaluate integrals that involve expressions of the form a squared minus u squared, a squared plus u squared, and u squared minus a squared using trigonometric substitution. And to start, so here is the detailed step-by-step solution on how to evaluate integrals using trigonometric substitution. The method of trigonometric substitution can be very effective when dealing with integrals when the integrand contains the expression of the form a squared minus u squared, a squared plus u squared, and u squared minus a squared. So the three basic substitution are as follows. When the integrand involves u squared minus a squared, then use the substitution u equals a sine theta. But if the integrand contains a squared plus u squared, then use the substitution u equals a tangent theta. And the last, if the integrand involves u squared minus a squared, then use the substitution u equals a secant theta. Okay, suppose you're given the integral of x cubed dx over the square root of 4 minus x squared. So because the denominator or the radicand is of the form a squared minus u squared. So we can rewrite a squared as 4 and then u squared as x squared. By taking the square root of both sides, so we get okay, suppose you're given the integral of x cubed dx over the square root of 4 minus x squared. So because the radicand is of the form a squared minus u squared, where a squared is 4 and u squared is x squared. So from this equation, we can take the square root of both sides. So we get a is 2. Same with u squared equals x squared. U is equal to x. And because the radicand is of the form a squared minus u squared, so we make use of the substitution u is equal to a sine theta. Okay, where u is x is 1, and then a is 2. So we have x equals 2 sine theta. Then taking the differentials of both sides, so dx is 2 cosine theta d theta. So from this equation, we divide both sides by 2. So we get the sine theta is x over 2. Where in the right triangle, if this is your reference angle, sine theta is opposite over the hypotenuse. So therefore, the adjacent side is the square root of the square of the first of the hypotenuse minus the square of the opposite side. And then by rewriting this as the square root of 4 minus x squared, where x is 2 sine theta. So replacing x by 2 sine theta and taking the square, so we can rewrite this as 4 minus 4 times sine squared theta. And then we factor out 4, so we have 1 minus sine squared theta. But recall in trigonometry or in trigonometric identities that 1 minus sine squared theta is cosine squared theta. From sine squared theta plus cosine squared theta is equal to 1, we can solve for cosine squared theta as 1 minus sine squared theta. Then extracting the square root of 4 is 2, and then square root of cosine squared theta is cosine theta. Okay, so therefore, we can now rewrite the integral of x cubed dx over the square root of 4 minus x squared as equal to the integral of, what's the value of x? From this representation, x is 2 sine theta. So by substitution, we have 2 sine theta quantity raised to the third power times dx, where dx is 2 cosine theta d theta. Okay, divided by the square root of 4 minus x squared, which is equal to 2 cosine theta. And because this is common, so we cancel this out. And then we take the cube of 2. So we have 8 times the integral of the cube of sine theta is sine cube theta d theta. And recall that the resulting integrand can be integrated by using the trigonometric transformation, wherein we rewrite sine cube theta as product of sine squared theta and sine theta. So this sine theta will serve as du, because if we let u as cosine theta, then the derivative of cosine is sine theta. But because sine squared theta is not yet in the form of cosine squared, so we use the identity sine squared theta plus cosine squared theta is equal to 1. Tapos you solve for sine squared theta. So we have 1 minus cosine squared theta times sine theta d theta. And then by distributive property, this can be written as 8 times 1 times sine theta is sine theta d theta. Minus 8 times negative is negative 8. And times cosine squared theta sine theta d theta. Okay? But what is the integral of sine theta d theta? Recall that the integral is negative cosine theta times 8. So this should be negative 8 cosine theta. That's 1. And then minus 8 times, so minus 8 times the integral of cosine squared theta sine theta d theta. So by power formula, you let u be as cosine theta and then your du as negative sine theta d theta. So by substitution, we can write the first term as negative 8 cosine theta minus 8 times, if we let u as cosine theta, then this should be u squared. And how about sine theta d theta? So you solve for sine theta d theta by multiplying both sides by negative. So this can be written now as negative du. Okay, that's the sine theta. You divide both sides by negative 1 or you multiply by negative 1. So sine theta d theta is negative du. Or this can be written as negative 8 cosine theta minus, so this should be positive 8 times the integral of, what's the integral of u squared du? So this is power formula, no? The integral of u squared du, this is u cubed over 3 plus the constancy. But recall the right triangle, theta with the opposite side as x, hypotenuse as 2, so the adjacent side is 4 minus x squared. So solving for cosine, this should be negative 8 times cosine theta is, it should be square root of 4 minus x squared all over 2. Okay, plus, this is 8 over 3 times u cubed, but recall that u is 4 minus x squared raised to 1/2 raised to the third power plus the constancy, or negative 8 divided 2 is negative 4 times the square root of 4 minus x squared. Okay, plus you have 8 over 3 times 4 minus x squared raised to 1/2 raised to 3 is raised to 3/2 plus the constancy. So this is the final answer. So in summary, if the integrals contain expressions of the form a squared plus u squared, a squared minus u squared, or u squared minus a squared, then use the following trigonometric substitution. So for integrand with a squared plus u squared, then use the substitution u equals a tangent theta. Then if the integrand contains the expression a squared minus u squared, then use the substitution u equals a sine theta. And for u squared minus a squared, use the substitution u equals a secant theta. But make sure that before using this method, the integral should not be integrable using the simple substitution.